Good morning. My name is Arun. I work on Uber Eats in the Uber New York office and engineering team there. Here to talk about the React Native use at Uber. Who here has tried Uber Eats? A few of you. Slowly growing number in New York. We launched in New York about a year and a half ago. A lot of work to do, but it's a business that's about 2.5 years old at this point and growing at a pretty rapid pace. So here to talk about a lot of the things we use React Native for on the restaurant side. Quick background on Uber Eats. Most people know us for the ride-sharing business, but on top of it, we built a pretty successful business on the Uber Eats side of things. The idea is to make eating effortless at any time for anyone. Like most things at Uber, it starts out with an experiment. We built something in 2014 in Los Angeles. We called it Uber Fresh. Idea was instant access to a lot of things that are sort of finite in nature, but still carried around by a truck or a van. Things like toothpaste, or we experiment with things like even beer, and try to figure out where there's consumer market fit, a product market fit here. Food became a pretty interesting niche. In 2015, we kind of started to focus strictly on food. You may have seen sort of Uber Eats Instant, which was a product that we actually experimented with in New York itself. Instant Eats is all about a finite selection, but 5-minute delivery. So we were optimizing for speed more than selection. Over time, we kind of realized that selection matters a lot more. Late 2016, December 2016, in Toronto, we launched the Uber Eats app, and here we are scaling and going beyond. You can actually kind of see how it started on the leftmost, I guess your rightmost. You'll see it was actually a feature in the Rides app. The metaphor doesn't quite carry, but you can like slide the slider and instead of a ride, request a meal. But it helped us innovate and try things out. At the end, all the way on the left, we have a standalone app that lets you order food and search for things and ask for things. The ecosystem is actually slightly more complicated. So ride sharing is a two-sided marketplace. You have the rider and driver. On the eat side, it's three-sided. So you have the restaurant, who has the food, they make the food, they sell the food, the eater who's hungry, and the delivery partner or the courier that picks up the food and delivers the food. And Uber's in the middle trying to mediate all of this and trying to make sure everybody's happy. So that one additional side of the marketplace makes things a bit more complex. I specifically work on all things restaurant related, and happy to kind of dig into how we use React Native there in a pretty broad base there. Here's the older version of the app. We actually started it out as a web view. So as probably have seen a lot of experiences go, the team that originally built this was a team of web engineers. They built this for merchants, and then eventually became a restaurant tool, and kind of talk you through our journey there. Here's the more modern version of it, much more touch optimized, looks a lot nicer on a tablet, and kind of walk you through how we built that. There's also other tools for restaurants we build. These are pure web apps, but at some point we'll make them into native mobile apps as well as the demand is there. The idea is to get more intelligence into how your restaurant is performing. This is the driver side. Lots of cool things we've done in the past around like showing step-by-step walking instructions, because picking up a passenger is very different than parking your car and going inside a mall and picking up the right meal. So walk through the restaurant app really quickly. So I think a lot of folks may not have seen it. I actually just like cut and paste this from our manual, so the resolution's a little funny. But I think it does a good job of what the app does. It lets you see new orders. They chime at you. New orders come in. You can kind of track them. You can click into it and see what the order detail is all about. Order accuracy is super important. If you say you don't want something or you want to add on something, it's really important that it comes through. The food business is quite complicated. We've learned a lot of things. People get very hangry when you mess up their orders. So it's very important to kind of track the specifics about the choice of broth or spicy level and stuff like that. You can manage the order. You can track orders in progress. We have a pretty good sort of like prep time model through machine learning that tells you when we expect the food to be ready. That's driven by the back end. Food orders that are ready for pickup are tracked. On the right side, you can see couriers arriving and kind of going through that. Order handoff is another sort of part of the app where you can kind of tell which courier is arriving and what meal goes to them. So order numbers and things like that need to be super accurate. And then kind of see the order history. You can get support. And if the demo gods are with me, I'll try to do a quick demo because I think it's always helpful to kind of get a sense for what the app looks like. So what I'm going to try to do is just boot up the app, and from my test restaurant, place an order. Nothing exciting like a demo first thing in the morning, so fingers crossed. If it doesn't work, you'll just have to take my word for it that it works. Cool. So the app is booting up. So if who here has used React Native extensively? Cool. So the sort of the feel of this is all pretty familiar to you all. The Metro bundler serves the JavaScript file. Our app boots up. Oh, the resolution's wonky. Crap. What's that? Where is the resizer? Oh, yeah. Nice. Never try this with a remote monitor. Thank you. I don't write a lot of code on this stuff anymore. So, cool. Let me just pull up the app really quickly and place an order. And you can kind of get the sense for what the app feels like here. So it's my test restaurant. Hopefully I can place an order. Let's see here. Add to cart. Just using the Uber Eats app, just so we have a mode to like go into the test restaurant flow. Order comes in. You know it's the debug build because the warnings are showing up. If sound is playing, there's a lot of work done to have native sound playing work. I can accept the order. And showing the courier flow is extra complex. I'm going to skip that part. But you can assume that there's a separate app which the courier can arrive, and the order states kind of forward through in the state machine. So I'm just going to cancel the order. So that's the sort of the app where you can kind of see the details, kind of navigate around. You saw at the beginning there was a little loading animation. We used Lottie for that. The little sort of like pulsating animation. All of it feels very smooth on our device. All done natively. So that's the app. We actually built a web version of the app too. So we have about 93% code sharing across 3 platforms: iOS, Android, and web. In developing markets like India and Brazil, tablets are actually not desired. They have like a laptop in the back office, and they just want to have all their delivery systems, accounting systems all running off that same laptop. So you can see the same sort of experience, but running in a sort of a Chrome window. Pretty cool. There's actually a really cool plugin called React Native to Web. So kind of an interesting thing that we wrote React Native code, use views and all the native sort of like modules you'd expect, and then we're able to swap out components and have just it compiled back into divs and whatnot. Pretty interesting process. We create a bundle, deploy it to a website, and it's just a single page app that runs. Very cool. So now here to talk about that, obviously. So kind of dig a little, so now you have a sense for what the business is, what the app looks like. Talk a little bit more about the scale. So we are a team of 6 engineers. We support iPads, Android tablets, and web more recently. We started out on just iPad. So we, at one point, were the largest procurer of iPad mini 1s in the US, refurbished. 6-year-old device. I think at this point we're no longer super into that tablet, but we're doing a lot of work on Android, much more scalable, global ecosystem, and also obviously a fraction of the cost. So we've been pretty happy with Android. It was interesting because we chose React Native not because of cross-platform. We chose React Native because the team had a lot of web background and we had to get to iPad quickly. And the original sort of like iPad app that we shipped, there were all sorts of weird issues where I think it was iOS 8 or 9, where a web app couldn't play sound unless it was first interacted with. So we'd have to do interesting things like when the app would load, we would have to have a pop-up that would incite like a touch, and then the Safari browser will let you play sound. So it's pretty clear that we had to go native, and I'll talk about that process. But then huge win in that we're able to go to Android pretty quickly, and then a surprising win that we could also share so much code with the web. About 100, these are some of the last published numbers, 120,000 weekly active restaurants, 35 plus countries, 280 plus cities. As of first quarter, our run rate was $6 billion of food sales a year. So you kind of compare that with like other sort of food chains to kind of see how much food we sell. The market's still nascent though. There's still a lot of restaurants that take orders via fax. So like there's a lot of room for technology to do some good here. And also our own business, from everything we see as we expand, the market's quite large, especially when you bring convenience and selection at a good cost. So some of the stuff is covered in a blog post that we published a year ago. So yeah, we have this sort of like web app working okay. How do we slowly migrate this to React Native without sort of bringing down the business? One of the things I'll keep reiterating with this tablet app is that this is the app through which restaurants sell food, right? And it is not an app like where the Rider app, where you open the app, push a button, get a driver, and then you background it. The app has to be up and running 24/7 in many cases. So downtime and all of that has huge repercussions, which I'll talk a little bit about. The very first view, what we basically did was we used React Native, but we kept as a web view and just kind of like injected JavaScript back and forth. Later on, we kind of converted into sort of React Native UI itself, using the view components and stuff like that. But in the very first go, we kind of just kept as a React app and then used React Native for just things like sound and printing. But we realized that to do things like animations and nice experiences, the whole app has to become native over time. So it's a migration from WebView to kind of ease the migration. At Uber, we have a lot of libraries for things like logging, analytics, crash reporting. So an early sort of hunch we had was, why don't we just wrap everything and keep the native libraries in every platform, and kind of just like do very little in JavaScript as needed. But then we realized that it's actually better to, in some cases, rewrite it into pure JavaScript just to kind of reduce the amount of context switching you have to do. So if it's just a simple RPC call to send up an analytic event, maybe it's better to just rewrite it in JavaScript. If it's something like crash reporting and you have to hook into native sort of exception handlers and things like that, that is probably worth keeping in native. But we actually were not shy in kind of rewriting things into pure JavaScript, even at the expense of reducing some reuse from existing core Uber systems. The context switching was real, where you had to kind of say, okay, well, I'm emitting this event, here's the bridge, works really well, but once you have to dig into the code, Objective-C and Java, it's just too much for a single engineer to handle. So we have one of the things I'll talk a little bit about is our code push process. We use Fabricator and Jenkins for our build. We have one of the things we actually very early on wanted to do was iterate very quickly on this platform. So we actually have a really cool mechanism by which there's code push. This was before Microsoft opened up their code push platform, so we had to write something from scratch. And it's actually pretty cool. I hope at some point we'll hopefully open source this as well. But the idea is that at any given point, the app has 3 bundles, up to 3 bundles, I should say. One that it's packaged with, one that it's currently running, and third one it just downloaded from the internet. So every few minutes, we check to see if there's a new bundle. If so, we pull it down. We go through a validation process, which basically is look for JavaScript exceptions or native exceptions. And if it passes, we sort of delete the old bundle and keep the newly fetched bundle. The fail-safe is whatever bundle the binary was shipped with. So that's always kind of kept around for posterity if we ever have to pull that in. So you can kind of see original JS bundle, last stable bundle, and latest bundle. So this is something that was very important for us to get right for a small team, but also because, as I mentioned before, restaurants are, in many cases, especially our large partners, are 24/7 business, and these tablets just sit there until they're needed. So if an app crashes or if it pauses, there's a big mess there. So pretty proud of the code push process. Works really well. There are some areas where we're iterating on in terms of like monitoring which build is in what devices. That requires a lot of like log parsing today. So we'll probably improve that as well over time. So here's sort of that flowchart I called out. Load the bundle, see how it is. Is it safe? If it's smart safe, delete the old one and continue. We use Flow. So if you've written a lot of JavaScript, you'll know that it's not a very type-safe language by design. We use Flow. So here's a simple reducer that takes a state and returns a state. State has an initial state, a sort of variable. So super important to get that right. One of the things that became a huge boon for us is Redux sagas. Redux sagas allow you to have these sort of long-running tasks that work with our native layers really well. So here's an example of keep calling fetch orders at a given delay, and it's a generator function. If you've not done JavaScript much, this code should still kind of make sense. It's just kind of some interesting syntax on top of it, but it's actually really, it makes a lot of sense. And you can kind of like turn generators of generators. So this is basically if login success happened, then go start fetching orders until logout success happens, right? And this take syntax is basically look for them and then kind of yield to that. You can write really generic versions of this that, I won't get into that too much because it's more Android focused. Some of the tablets we support, it's just in a sort of event next to me, all the different things we have to test with. Some fun things is around the external peripherals we have to support. So printers are actually quite interesting beast. Lots of like custom rasterizing events that has to be sent. I'll kind of flash some code that we wrote for this. Star and Brother, and these are some big brands. And what's interesting is this printer is faster and better than this printer. But guess which one is more popular in restaurants? So you have to kind of support sort of the simple Android print and Bluetooth APIs, but you also have to kind of work through the serial interfaces where you're sending like, almost byte by byte information over the wire. And thankfully there are some good jars we were able to use that and bundled around with React Native ourselves. So we didn't have to write some of the low level stuff. Different sort of types of printers. So some printers can do branding and like nice patterns. Some printers are very like dot matrix style. So we had to kind of support that. I'll go through a very quick debugging experience we had. This is on an iPad, but I think the same sort of issue also, similar issue happened on a tablet as well. Generally speaking, we've been pretty like happy with like how quickly we can debug things. We had a pretty complex issue with a large restaurant partner of ours where the tablets were kind of going offline after a day. So the symptom was they start the app up, and then a day and a half later, the restaurant will not be available on the Eater app. So that was a symptom. Took us lots and lots of debugging to figure out that it was probably a memory issue. And the correlating event was they had recently upgraded to this new version. As we all know, newer not equal to better. But the issue really kind of became really hard to kind of like figure out because there's Xcode tells you there's no, I'll show you a couple of screens there. There's a lot of like minor leaks we figured out that we fixed, didn't quite yield. The networking issues were kind of weird too because these devices run in these wired networks or captive networks at these restaurants. It's kind of hard to tell it was really a networking issue. We knew it was a memory leak because we started seeing some spike in some memory warnings before the app crashed. So kind of all that came together. The problem with React Native that we found that I think we're still getting better at is the native tools tell you one thing, the experience tells you one thing. So in this case, this is Xcode instruments, tells you there's no leaks. Ran it multiple days at a time, it just couldn't detect a leak. It just doesn't know how the JavaScript engine allocates objects in some cases. The native JavaScript debugger, which is using Safari in this case, we finally originally kept implying no leaks. Finally, we got a bit of a hint when we found some snapshots we could compare and found like slow growth in, by like 20, 30 kilobytes at a time. That took us a long time to figure out. The real issue was we had the pulsating animation that I demoed really quickly. That was yielding a massive leak for us. The callbacks were not being cleared up. So we're like, this is crazy. This code leaks, this code doesn't, and the only difference is this uses a sequence call, and it just starts. This does a loop, and we introduce like a active stop call, so we can stop and animating when we want to. Very straightforward. Once we figured out, 5-10 line change. We were like, this is crazy. Nowhere in the documentation does it say like sequence requires a manual cleanup. We just figured if the view is unmounted, all animation that it spawned are automatically cleaned up. We logged a GitHub issue. We're trying to put up a PR to fix the issue. And someone said, no, that's how it's supposed to work. So, it's just a matter of us learning in a lot of cases. So these are some of the initial interesting things that we have kind of gone through, especially with debugging sort of the boundaries. These are some of the native integrations we use. Fetching blobs, map integration. We show where the courier is. We fetch the zip file, so we have to unzip that. There's no native libraries for that, so we had to use a plugin. Sound, Lottie, pretty happy with Lottie. It actually works really well on iOS and Android. So that was just like export from, forget the tool the designers use, but it worked really well. And then we did a lot of custom sort of wrappers ourselves for things like printing, Bluetooth, some of the file services, and then some of our own internal libraries. Kind of just very quickly, flash like how we mount and dismount our native libraries. So this is like the set of interfaces where like analytics.add event emits into a wrapper. Beacon.start broadcasting, because we use some Bluetooth technologies to kind of detect when the courier arrived. So we can kind of call these functions into the native bridge layer. And then I kind of talked about Beacon. So Beacon.start broadcasting. So registering the function calls there. And here it is in Java. They're exposed via the annotated React method. And you can kind of see what it does here. This is the interface, and then the implementation detail kind of sits in another place. Kind of try to hide some of the complexity there. But that's the idea. So you kind of see like my native module is called Beacon. The methods I want to expose are start broadcasting and stop broadcasting. Works really well. The bridge is quite good. And here's some of the gross sprinting code, where it's sort of like checking the port and sending commands, checking to see if the cover is open. Weird states that you don't normally think about. So kind of just like copied that code without trying to turn it into pseudocode. So went by pretty quickly, but kind of wanted to at least talk about some of our summary learnings. So we started React Native in 2016, still pretty early days at that point, but we went there because of our skill set, not necessarily because of some like massive research of cross-platform tooling. We were originally only thinking about iPad because that was, what US-centric mindset at that point. We're still on React Native and we're pretty happy with it. In fact, if we build sort of restaurant-facing mobile apps, we may continue using a lot of the assets we've built. Some lessons were learned the hard way, but that's, I think, true for any technology that we go through. I don't think there's anything special here about React Native that perhaps some things weren't quickly Stack Overflowable. The community's still budding, but I think that was something, and I'm sure there'll be more lessons, especially as we ship this web version. One of the things that, within Uber, as with most companies, is always this like big debate about is React Native right for their team. I think the team part there is probably more important than whether the technology is the right fit. We had recently an opportunity where other mobile engineers could join our team, and it was not a good fit. Like, I think if you just want to write a lot of native Android app and this weird layer in the middle is going to slow you down or you're not going to be into it, I think that's hard to change. So it's just like a philosophical mindset that some people have. So we're pretty lucky in that our team is quite happy with it. I think there are other teams that would never go down this path at Uber, and that's okay. I think as long as like there's generic interfaces to our backend services, Jenkins supports us. We still ship a native binary, and we can use a lot of the normal technologies we would use. The technology with which the UI and some of the native interfaces are built actually doesn't matter at the end of the day. So we were able to get leverage, but we're not sort of pushing that across Uber. There's a lot of different teams with very strongly held views. So that's a big lesson learned for us is like, it's important to talk about your experiences, lessons learned, but when you start preaching, it becomes a bit of a religious war. Cool. So those are sort of the slides I had prepared. I'm happy to kind of go into more questions, answer any thoughts, questions, ideas. Yeah.
The consumer eater app React Native? Or?
No, the consumer eater app is pure native app, so written in Objective-C and Java.
And then you also talked about this like memory leak issue. In the future, did you add more monitoring to prevent this so you don't have to rely on like a customer report?
Yep. Yeah, totally. Yeah. So we have good monitoring already. So if you notice, like we had graphs of like memory events and stuff. We added even more things. One thing we didn't have was the actual footprint. So iPad Mini 1 has 512 megs of RAM. Our app in healthy state uses about 110 megs of RAM. We probably should have kicked off some alert when it went above 200, 250. So iOS crashes you about 250. So we should have known and tracked that better. So big lesson learned was report specifics, not just like these sort of random events.
How much of the rest of Uber's infrastructure do you integrate with? From native libraries, tooling, build, CI, anything like that?
So we use the same CI system. Our internal, the way our app is distributed internally is not yet integrated. We sideload our app because these are captive devices. So it's not going through the App Store. So that's a TBD for us. I think there's a lot of wins if you do integrate. We use the same analytics libraries, or we rewrote some in pure JavaScript, which is actually helpful because the web teams then took advantage of it. We use the same authentication stuff, same backend protocols. So I would say like 75 to 80% of the stack is the backend stack, or the interfaces are shared. 25% probably very bespoke and custom to us.
So then how much of the time does your team have to spend updating as the rest of Uber moves forward and writing those bridges and maintaining that?
So I don't know if there's actually a talk earlier this week or a separate talk we've given. The rest of the Uber has moved to a monorepo. So one of the big problems is which monorepo do we sit in? There's an iOS monorepo and an Android monorepo. So we're still working through strategies of like, are we a submodule or are they a submodule with us? Do we just write some scripts? Right now we're a separate repo and we manually update dependencies. So probably once a quarter. But it's an open question as to like, how do we better integrate with the rest of Uber in that way? Good question. Cool. Any more questions? We'll also have a booth outside. I'll hang out there for a little bit. I'll be around here. Thank you. Thank you very much.